In this video, I'd like to show you how to create subnets within a VPC in AWS. So if you go to the VPC dashboard or just look up the VPC service, you will see a list of VPCs that you have available there. I'll go ahead and click on this. One of the ones that I just recently created is called Websites Production 2. It's got all of the default settings associated with that, and really all I had to do was give it a name, which is this over here, and an IP address range that it's going to be working with. And let me go ahead and click on it now. Now, as it is, this network is not yet suitable for adding in EC2 instances. EC2 instances get added to a subnet, and so a subnet is a subnetwork or a subdivision of a higher level network. So this network has the possibility of 65,536 addresses based on the math associated with this number. And I can subdivide that into different subnets. Currently, there are no subnets associated with this. If I come over here to the left side and I click on subnets, let me go ahead and click Create Subnet. And the first thing I have to do is select which VPC I'm going to be adding my subnetwork to. So I'm going to be subdividing this empty network that I just barely created. And I scroll down here. And at a high level, I want to think about how many subnets do I want. And I don't think I'm going to use all of the addresses that are available right out of the gate. I'm just going to use some of them. And the way subnets work is that you have to allocate them to one of the availability zones, which is equivalent to a data center. So even though your overall IP address scheme might range 65,536 addresses, you have to allocate some block of those addresses to a particular data center. And once you've done that, you're able to add EC2 instances to that particular subnet. Now, in production, usually you'll want to subdivide your network from your overall VPC into all of your availability zones, and then this will allow you to do things like have fault tolerance by adding EC2 instances into multiple data centers or availability zones, and you can distribute your web traffic or whatever traffic among all of those locations, and if one of them goes down, then others are still available. So with my overall 10.0 VPC that I recently created, I want to put some set of that into this first availability zone, and I'll call this, since this is my production environment, I'll call this production 1, or maybe I'll call it production, because I called this already up here, I called this websites production environment 2, so I'll call this 2A. So that'll be one place where I'll put some of my IP addresses, and the overall network is 10.0.0.0/16, and this means that I can manipulate everything that's after the first two zeros. So everything down here is available. And so because I have some networking knowledge, I'm going to do 10.0.0/, and I'll do 24. And what this means is that from 0 to 255 are going to be allocated as part of this network. I'm going to create another network in a second where I will make that one 1.0, and then again /24, and that will be a completely different subnetwork. And I'll put that in the other data center or the other availability zone. So I just needed to give it a name. I gave it an IP address block. So this is going to allow me to have 256 different addresses in here out of my overall 65,536. I'm going to go ahead and click Create Subnet. It's been created. Let me go ahead and create another one. So I'm again using this Websites Production 2, and I'll call this one Subnet, 2A, or maybe it's Production 2A, I've already forgotten. Production 2A, and instead of putting all of the IP addresses in that data center or availability zone, I'll put it in this one. And for this portion of the network, I will do 10.0.0.1.0/24. So just this will be changing. So as you saw, as I was doing things, or the pattern I'm using, I could do 2, 3, 4, 5, 6. I could have lots of different subnetworks that have 256. I could also use more of my overall scheme by choosing different numbers here, but hopefully this is understandable enough. I've created now 2 subnets, each of which have space for 256 IP addresses in each of them, and I could put EC2 instances in each of my subnets. Okay, so I just created this second one. If I wanted to see all of my subnets, I could go right here, but I want to see some greater detail about this subnet that I just created. Now, I only updated 2 things. I gave it a name, and I gave it, and I associated it with a VPC, and I also gave it a CIDR block, which gives it a certain number of IP addresses. So let's investigate what we have here. I can see that this particular subnet has 251 addresses available in it. The reason why I don't get all 256 is because some of these are reserved in each subnet for networking capabilities that AWS is using. So in this list, I see the VPC that this subnet is associated with. I see which availability zone it is in, the original CIDR block that I chose, and then some other things that I think are important here are these blue links. So if you create a VPC and don't give it any entries, well, you don't have to do anything really. You just, when you create it, it automatically assigns your VPC to a default network access control list, which is a default firewall. And because I created this subnet within a VPC, which is associated with this firewall, it got associated with this firewall. And this particular default firewall just allows all traffic in and out, no restrictions. The NACL, as it's called, is something that operates at the layer of the subnetwork, so it filters traffic going into the subnet and out of the subnet specifically. Okay, and then there's another thing worth looking at here, and that's the route table. So the route table is for routing traffic or handling traffic that originates within the network so that the subnetwork as a network service knows where to deliver the traffic. So think of it like a postal service. It listens for traffic that's coming into it and it tries to figure out where it's supposed to go. If I click on a route table, and this is assigned to a default route table right now, I can click on, first I see its name, and then I'm going to click on routes right here. And here's the route. It says 10.0.0.4/16. So it's listening for traffic that is within this range. And if it sees any traffic in this range, it sends the traffic locally. Now that probably doesn't sound intuitive at this point. So I clicked edit it so I can make a change here and isolate this here. At a high level, what this is saying is that for within this subnetwork, if any traffic is being passed around that fits within this address block, it is going to try to deliver it within the local VPC. Notice that this is the address range of the VPC. So local is kind of a way of saying within AWS's environment that anything within this range is destined for the VPC itself that you're currently in, and so try to deliver it to within one of the subnets that are there. Now you could add in other destinations. So some of the stuff that would come up here is if you have something that's not within this address range, for example, stuff out on the public internet, you will usually add in an entry here that associates your subnet with what we call an internet gateway, which is an intermediary service between your network and the internet. So if your devices, your EC2 instances, need to do something like pull down your code from GitHub as they boot up and as they launch in order to be configured, In order for them to do that, they need to have access to the internet. And we're not talking about firewalls here. We're talking about a physical path to get to the internet. And in order to do that, you would create an entry here and associate it with an internet gateway service within the AWS environment. I'm not going to add that in this video, but at this point, all this network and this subnetwork will allow us to do is pass traffic to the local VPC.